videos to get you to understand the change of base formula and then how we would possibly use it. This is a printout from a textbook, your textbook, that actually talks about the change of base. So we're going to get some practice looking at text here for a minute. I'm going to zoom in a little bit because there's a couple of things I want you to see about this. First of all, technology note. Your calculator, it says some calculators. Your calculator now has the ability to go to any base. I mean, when you guys hit log on your calculator, the Inspire, that is, it says already what base do you want. Well, it didn't used to be that way. You could only do base 10 or base E. So you actually needed to do something called change of base just to put it in the calculator if you had a different base. All right, so we don't need it to put it in the calculator, but the properties of change of base are still important and they can help us solve problems and apply logarithmic problems. So here's the change of base formula, and I'm going to kind of talk it through with you a little bit. So again, this is setting up the formula that we've kind of talked about. I'm not going to try to confuse you with that right now, but it's basically setting the guidelines for the possibilities here, okay? We've already talked about that a little bit, we have this year. But look at this right here. Look at the left side. What this is saying is if you have any logarithm, base A of m. So if you have log base A of m, you can rewrite it into a division of logarithms. Now be very careful. That is not the same as the properties we've been talking about, where if you have log base A of m over n, like this, that it turns into log base A, base A of m minus log base A of n. Like that is true. That is a true property. That's not what we're discussing right now. What we're saying is you can take this, rewrite it as a quotient, but look what happened. The bases became b on both of them. So this argument became m, and then the base that we had before became the new argument here. And then we have the two bases, whatever we want. We can pick whatever we want for those bases. We just can't pick one. Okay, so I'm not going to go through the proof of it right now, but what I'm going to do is just get you, there's an example down here so you can see it. So again, log base 5 of 89. All right, well, first of all, I do want you to think about it. Don't look ahead. Just process this with me. If this says log base 5 of 25, I'm hoping you guys can say 2 by now, because 5 squared is 25, right? 5 to the third is 125. So since it's 89, we know that our answer should come out to like 2 point something. Well, just look at how they do this. Just kind of process how they're doing change of base here. Log base 5 of 89. Pretend that we can't put that on our calculator unless it's base 10. Well, then we can write it as base 10. Common logs here. There's a base 10, and then the argument, this goes in the numerator, that goes in the denominator, and when we actually do that division, we get 2.7889. Okay, and likewise over here, this is log base root, oh, sorry, that one's not shown on here. So, this is, don't worry about that one right now. Sorry, that was my bad. But right here, as you can see, this is the exact same problem, just a different way. You can choose to use the natural log of 89 divided by natural log of 5. That's totally fine. You get different numbers here, but the ratio is the same, and you get that. So we can use change of base. So here's a way I could assess this question. I could say to you, log base r of 3. Rewrite that using change of base. Well, since you can't put that in your calculator, since there's a variable, you could easily just be like, okay, that's the natural log of 3 divided by the natural log of r, and that would work. Like that is an equivalent representation of this right here. And we'll see more as the week progresses. But how could we use this? You don't have to use this on problems, but look at this. Like I have a property for putting these together, right? But what don't I have? I don't have common bases right now. That's a 2, that's an 8. So if you think about this a little differently and be like, all right, well, how do I get a common base? Well, it might take some, watching before you get the hang of this, but this should hopefully be true to you, that if I do log base 2 of x minus, and then use change of base right here into base 2. If I change this into log base 2, wouldn't that be log base 2 of x divided by, think about it, if I changed this to base 2, what would the denominator be? hopefully you were thinking log base 2 of 8 equal to 6. So this is completely equivalent to this, it just looks different. Okay? Now why would I do that? Hopefully you're thinking ahead here, maybe. And what is that? Log base 2 of 8, I know, that's really the number 3. So instead of thinking about that as log base 2 of 8, I can make it 3, and now I've got everything in the same logs here. So essentially now I have log base 2 of x minus 1/3 log base 2 of x, and that equals 6. Well, instead of using a property, think of it as like terms. I've got 1 log base 2 of x minus 1/3 log base 2 of x. So what do I really have? I've got 2/3 log base 2 of x equal to 6. Well then, we can take this, and there's multiple ways to solve this, but we can take this and put that up there. So now what do I have? Well, I've got myself log base 2 of x to the 2/3, sorry, it didn't show up the best there, equals 6. All right, well, what now? Well, now I can convert that to exponential form. So I can do 2 raised to the 6th power equals, what? 2 raised to the 6th power equals x to the 2/3 power. We could do that, all right? But then where would we go from here? Well, there's multiple ways we can process this problem. I can't remember what I put over here. I want to look at it real quick. Okay, I did do this one. I was going to show you 2 ways, and I ended up showing you this way anyways. All right, but actually, I can just let you kind of watch this out from here. You could convert this into, as you see, 2 to the 6th, then you're getting 64, and you're processing this through. Well, what is that? This right here is the, remember, 1/3 power, so it's the cube root of 64, right? Cube root of 64 is how we could do that, but this is actually flipped when you get to that. So that one's a little bit trickier to go through as far as this process down here. It's definitely doable, but at this point right here, I guess I can scroll down to show you how I would process this differently. 2 to the 6th is 64. Right? That is 64. So we've got x, and this is going to be the cube root of x squared, right? Like 1/3 is really the cube root. So what could we do? Well, we could actually think of this. I mean, there's a couple ways to think about it. You could think of this as 64 equals the cube root of x, and then put the squared out here. So then, one way to do it would be to take the square root of both sides, and then you would just have the cube root of x equals 8, and then we could cube both sides. Sorry, that's getting a little sloppy there. And then x equals 8 times 8 times 8, which, if you don't know what that is, don't you know that it's 2 cubed? That's 8, right? Cubed. So what is this? This is 2 to the 9th power. Same thing, you're going to end up getting what? 512, which is what we have over there, so 512. All right, that was a little bit intense for that here. I think some of you, and you can think of that way. That's fantastic. There's nothing wrong there. Another way to process this problem way back up here. Let me get out a different color here. Okay. So another way to process this problem right here would be to look at this problem as I have subtraction of logarithms with the same base, right? So what I can think about it is log base 2 of x on top, and then what would be on the bottom? Well, what does this really say right here? It says log base 2 of x divided by 3, but there's really a 1/3 out front. So this right here would be log base 2 of x, but it really has a negative 1/3 or a positive 1/3 if we think about it like that. And then this can go up here and be the 1/3 power. So that's really x over x to the 1/3 power. If you like doing it that way, well, look at this. Now we're going to have this, which is still equal to 6. Now we're going to have log base 2. What's 1 minus 1/3? Well, that's x to the 2/3, and that equals 6. And we're still going to have to go through and convert to exponential form 2 to the 6th equals x to the 2/3 problem, okay? So then we're, essentially back to there. The rest of it's going to be the same. But there's two different ways to process this, okay? Now, next, one more example. Hold on. I want you to just process one more and then give these a try. Each problem is different. Okay, but this one right here, we can do change of base. You don't have to do change of base all the time, so don't make it like your go-to. But since I have a variable in each logarithm here, it's going to cause me to do change of base. So I don't want to change this to base 1/9. I'm not saying you couldn't process it that way, but I'm going to go to base 3. So watch what happens. I have log base 3 of x over log base 3 of 1/9. Okay, and the reason I'm doing that, hopefully it's already been an indicator to you as I did it, but you know what that denominator is, right? Right. Hold on. You know what this is. 3 raised to what power would actually give you 1/9? And hopefully we're getting better at that, but that would be, oops, did not mean to have yellow there, sorry. That'd be -2. So again, what do we have? We've got -1/2 log base 3 of x plus log base 3 of x equals -2. So what does that mean? I can put those together if I wanted to bring this power up, right? So let's practice that. This right here, okay? They ended up being like terms here. That won't happen every time, so I do want to show you this. So now I have log base 3 of x to the -1/2 power, as we can see there. And then I have what? Plus log base 3 of x equals -2. Addition is going to be a single log base 3 of the product of these two. So if I took x to the -1/2 times x to the first, what would we do? We would add those together. So I would really have x to the 1/2 power, and that would be equal to -2. Well, now that I'm here, that's a 3 right there. Now that I'm here, I'm going to convert to exponential form. So 3 to the -2nd power would be equal to x to the 1/2 power. Well, get some more space here. That's really saying 1/9. That's what that is. That's 1/9 is equal to the square root of x. So how would I solve something like this? Where I could square it. And what do I get? I get x equal to 1/81. And then on all these, I kind of went faster because I was showing you that you want to show and make sure that they work out, plug them back in, check for extraneous solutions and all of that. But we got that one. Now that one might have been, now that I'm thinking about it, might have been better just to show you that example. That was a little bit less complicated than the other one, but give it a try. Thank you for bearing with me and staying with me through this. All right, so we can change the base. That's the main lesson here. We can change the base if we do it appropriately to help us solve the problem. Hopefully you are going to understand it and be like